Algebra 1, Common Core, Unit 6, Section 2, Linear Systems, Algebraically, Substitution. So there's not a video for 6.1, but if there was a video for 6.1, it would be Linear Systems Graphically. I didn't make a video for 6.1 because we just finished graphing lines, and all you did in 6.1 was, graph two lines and tell me where they cross. So there was really no material in there that required a video. It's just graphing linear equations using the slope and y-intercept and, maybe your graphing calculator to help you here. Well, linear systems algebraically is also, I want to know where two lines cross, but I'm not going to graph them to find out. I'm algebraically going to find out where they cross. And there's actually two different methods that we're going to cover. Well, in this video, we're just going to cover the substitution method. There's a second method called the elimination method, which will be video 6.3. So that's your next video. But first, let's talk about substitution. And that's really nothing new. We've done substitution before. You've probably seen problems where if I gave an equation like y equals 2x minus 1, and I wanted to know, is the point 5, 9 on the line? One thing I could do is I could certainly graph this equation and see if it crosses the point 5, 9. But the other thing we could do is we could do substitution. I could substitute in the numbers 5 and 9 for x and y because that's what they represent. And I can see if it comes out to be true. So substitution is just replacing something with what it equals. Like in this example, I could replace y with 9 and 2 with x with 5. This y is 9 and the x is 5. So 9 equals 2 times x, which is 2 times 5 minus 9 minus 1. 2 times 5 is 10 minus 1. I get 9 equals 9. So the answer here would be yes, this point is in fact on this line. And the way we proved it was by using substitution. I can replace x with 5 because in this coordinate, x equals 5. That's what it's all about, And so we're going to do similar things here. So the notes here is that a linear system can be solved algebraically by using substitution. The goal is to have one of the systems solved for a variable and then substitute its equivalence into the other equation. And so that's, I think, a little bit of a confusing sentence without having, let me go a little thicker, without having an example, but luckily I'm going to do an example for you. So the goal is to have the goal is to have one of the systems solved for a variable. I think systems is probably the wrong word there. It's one of the equations solved for a variable. So let me cross that out and actually write equations. Together it's a system, but there's two equations in these systems. So we want to have one of the equations solved for a variable. So look at our example here. Solve this using that. Now notice what I mean by solved for a variable is you want something alone. And it doesn't matter if I have y alone or if I have x alone. Either one is fine. So looking at this, x and y are on the same side. They are not alone. Looking at the second example, x and y are on the same side. They are not alone. And so I want to first rearrange one of these so something is alone. That's what we're saying here. The first step is solving for a variable in either equation. Doesn't matter which one. This can be done by solving for x or y. Doesn't matter. There's typically one that's easiest. And what this goes on to tell you is that the easiest one has a coefficient of 1, if that's an option. Notice that the coefficient of x is 2, coefficient of y is 3, coefficient of x is 2, but the coefficient of this y is 1. You see no number written in front of it. That means it has a coefficient of 1. That's the easiest thing to get alone because I could just subtract or add things away from it. If I wanted to say get the x alone here, I could, but I'd have to divide by 2 to get rid of the 2. But if I have a coefficient of 1, I don't need to do any division. So the bottom equation becomes this. Basically, to get y alone here, I got to move this 2x to the other side. And because it's a positive 2x, I need to subtract 2x on both sides. Now remember, you have to be careful with, sorry about that, keyboard gets in the way sometimes. You have to be careful with the fact that, messing up all over the place. These are not like terms. And so you can't combine 10 and negative 2x, so you just write it as 10 minus 2x. Now, if we were concerned about mx plus b form, then maybe we'd put the negative 2x first, but that doesn't matter right now. That's not what we're doing here. We're not trying to write them in standard form. We're trying to get a variable alone so I can do substitution. So the first step is get something alone x or y in either equation, and we successfully do that. So the goal is to have one of the equations solved for a variable. Check, we did that. And then substitute its equivalence into the other. What we mean by its equivalence is, you see how if y equals 10 minus 2x, what that means is in the other equation, the one we haven't touched yet, you can replace y with 10 minus 2x because they're equal to each other. So what I'm going to do is I'm going to take the y in this equation I haven't used yet, and I'm going to replace that y with 10 minus 2x. Just like up here when I replaced y with 9 and I replaced x with 5, I'm just substituting this equal sign. Whenever you have an equation, that means that the thing on the left and the thing on the right are equivalent. They are interchangeable. You could replace one with the other. So I could replace that y with what it equals, 10 minus 2x. And so that's what this goes on to tell you. And so what you see here is the original equation. Here is when I do the substitution. Notice the change, that this y got turned into 10 minus 2x because y equals 10 minus 2x. Right? And, it's substituted into parentheses. And then, the key here is the reason why we're doing this is because now I'm left with an equation that only has one variable. There's no more y's. All I have is x's. And so I can solve for x. It has one variable. Doesn't matter if they're all y's or all x's. But it's hard to solve for something like here. I can't find out exactly what y is because there's an x. I can't find out what x is because there's a y. But you could solve an equation if there's just an x or if there's just a y. And that's what we did. That's what substitution does, is it takes away one of the variables and puts in the other variable. And so now I can do a little bit of distribution here to get this, combine some like terms to get this, minus 30, divide negative 4, and you can solve for that one variable. Then once you have the one variable, you can, just like we were doing, this whole time, since x equals 7, now that I know that, I can go back to one of my original equations and I can replace the x with 7. So instead of 2x, it's 2 times 7. And now I only have y's. Solve, I get y equals negative 4. Together they are the coordinate. You can simply test it by plugging in the x is 7 and the y is negative 4 into both equations, and they both will come out to be true statements. All right, let's try a couple from start to finish now. Okay, so here's, I think, 2 examples on this page. The first one is set up a little bit easier because the first step is done for us. One of our equations has a variable solved for it. So this has x alone, right? It has x alone. So that means we have that first step done of getting something alone. So what that means is in my second equation or my top equation, 3x plus 4y equals 7. Because I have an x equals statement, I'm going to replace the x with what it equals. And so instead of 3x, I'm going to replace that x. Now I still have the plus 4y equals 7, but I'm going to replace that x with what x equals, and that is 2y minus 11. And now it's just a simple algebra, I think, from here. We're just going to do some distribution. 3 times 2y is 6y. 3 times negative 11 is negative 33. Plus 4y equals 7. Remember, if I'm going too fast, pause the video, catch up. Here we got to combine like terms, but they're on the same side. So I'm not going to minus 4y or minus 6y. Just combine them. Positive 6, positive 4, that's 10y minus 33 equals 7. Same side like terms. Just combine them as they are. You don't need to move them around. Here we can add 33 to get 10y equals, add 33 on both sides is 40. Oops. And then divide 10, and we're going to get y equals 4. Then I can substitute in anywhere to solve for x. The easiest is the one that has x alone. So because we know x equals 2y minus 11 from earlier, I can substitute in my y equals 4. But really, I could have plugged that into the top equation or really anywhere that has an x and a y. But now I want to solve for x, and I'm going to replace y with what we found. So 2 times y is 2 times 4 minus 11. That's x equals 8 minus 11. X equals negative 3. Together, this is the point negative 3 comma 4. X comma y. Okay, I'll do one more quick example for you. On this bottom equation, again, get a variable alone. Look for something, if possible, that has a coefficient of 1. This does. So I want to rewrite this top equation as y equals 7, and I'll subtract 2x on both sides. Again, they're not like terms, so it just gets put next to it. Since y equals that, in my other equation, I'm going to replace y. So negative 4x plus 2 times, and I'm going to substitute in that 7 minus 2x equals 6. Notice in the previous example, I replaced x. Well, that's because I had an x equals equation. But here, I'm replacing y because I have a y equals equation. So whatever variable you have solved, that's the one you substitute in the other equation. And so I'm replacing this y with what it equals. Then I could go through the distribution here. This is going to become negative 4x plus 2 times 7, 14. 2 times negative 2x, negative 4x equals 6. Same side like terms, that's negative 8x plus 14 equals 6. Minus 14 minus 14. Negative 8x equals 6 minus 14 is negative 8. Use your calculator if you're not sure. And let's see, divide that negative 8, divide negative 8, and x is going to equal negative divided by negative, positive 1. Then again, the best place to substitute that in now, it doesn't really matter, but I like the one that has the y alone. So I'm going to use that again. Y equals 7 minus 2x now becomes y equals 7 minus 2 times 1, because we found x equals 1. That's y equals 7 minus 2, y equals 5. Together, this is the coordinate x first, y second. So x comma y. And again, I can substitute that in to verify it is correct. All right, that is 6-2 linear systems algebraically with the substitution method. In the next video, we're going to learn a different method to solve the same type of thing where we actually add the equations together and eliminate things. That's called the elimination method. See ya.